Welcome to the Rich Report, a podcast with news and information on high-performance computing. Today, my guest is from Hardcore Computer. We have the co-founder, president, and CTO of the company, Chad Attlesey. So, Chad, welcome to the show today.
Thanks for having me, Rich. It's a pleasure to be here.
You bet. It's my pleasure to have you. You know, Chad, I've been reading about Hardcore for a while. Probably because one of your advisors is involved with used to be with Sun Microsystems. So, but let's talk about the company. What can you tell us about Hardcore?
Well, Hardcore Computer was founded in January 2006. Started off on the market with submersion-cooled desktops and workstations, and kind of got our name in gaming. It was a Trojan horse approach, really. We got our name out there as the world's first submersion-cooled desktop supercomputer for gaming applications. It allowed us to get international exposure, got our branding out, and most importantly, it got our patented technology out in front of the entire world for a challenge, and to date we received none, and it's been an opportunity to get in front of a lot of people. And it was kind of, like I said, a Trojan horse approach because although ultimately we want to get into the data center with our products, about half the people who are in data centers are also gamers and they're part-time, so they know about us through that. So it's been a way for us now that we have a room full of data showing the positive aspects of submersion cooling, that we have much easier sell now going into the data center.
And sure, and it looks like, HPC looks like to be your inroad to the data center, kind of the people on the leading edge. Is that correct?
Yeah, that's true. And kind of surprising because initially we were looking at the energy saving aspect of what we were doing because you're able to pump all the liquid outside the data center and do the heat exchange and remove the air conditioning from inside the data center so you can cut your power in half roughly. But where it really took hold was the fact that because you're keeping everything cool, you can also overclock it to extreme settings and still have reliable operation. So the people in places like high-frequency trading, for example, HPC space, appreciate that because it gives them the most speed, but without sacrificing any kind of reliability. In fact, giving them greater reliability. And we're talking about power of the HPC server that saves. Like I mentioned, we have a server that we have the ability to circulate dielectric liquid through, remove heat, and then send that outside the data center. So we can remove the requirement for air conditioning inside the data center, which can cut your energy bill by half. It reduces your overall cooling cost by 80% or more, potentially, depending on how it's implemented. But normally, if you're doing something with efficiency, you're sacrificing performance or reliability if you're doing something with performance. And you can never seem to have all three of those. And with our product, actually, you get all three without any sacrifices. You get reliability, both on the millisecond, microsecond, nanosecond basis, all the way to longer lifespan because cooler components last longer. And since we're cooling everything, being in contact with dielectric, it allows for longer mean time to failure. So you get that reliability. But on top of that, because everything stays cool, we can bring it up to maximum clock cycle speeds, and you're pretty much only limited by what the silicon can do. So you get all those things. LSS 200 is our flagship product in this space, and like I mentioned, we can reduce cooling costs by 80%. It retrofits into existing 19-inch rack space. So you don't have to do anything with your data center. We provide a shelving unit that allows for 8 across and a 5U height. So you can get 16 processors and a 5U height. And we use tripless quick disconnects. If you look at that image there with those quick disconnects, they're military style, military grade, so that it's roughly 30 cycles to generate half a drop of liquid. So you don't have to worry about spilling liquid in the data center. And it is a dielectric. It doesn't conduct electricity. So even if you did have something that got out, it's not going to be damaging to your existing equipment in the data center. It's completely sealed, field serviceable. We offer a whole variety of different I/O and connectivity. And because it is a ruggedized enclosure, it's really deployable anywhere. You could literally put this thing in on a desert island somewhere in a pole shed. As long as you're doing adequate heat exchange somewhere else, it really doesn't matter because you don't have exposure to the atmosphere. You don't have to worry about salt air corrosion, high humidity, dust, sand, etc. It's completely sealed and designed to take a lot of abuse. So, and on top of it, with all these features, it's still designed to be relatively on price parity with the rest of what's on the market right now. That would be potential competition. Core coolant is what we use. It's a product that is a dielectric. It doesn't conduct electricity. In other words, it can be in direct contact with all the components, and I don't have to worry about the electronic shorting out. It's non-volatile. It doesn't require boiling in order to be effective as a coolant. It's non-corrosive. It's non-toxic. It's recyclable. And the most important thing for us is it's roughly 1,350 times better than air for heat rejection. In other words, you can contain up to 1,350 times the amount of heat per volume than you can with air. Because you're kind of up against the laws of physics right now with airflow. You need a ramjet practically in order to do adequate cooling, but you're really at that limit right now as well. And air is a great insulator. That's why you put it in the air spaces in your roof and your walls in insulation, but it's very poor at conducting heat. On the contrary, our core coolant is excellent at that. It's got a great thermal conductivity and thermal capacity. So we are much more efficient at getting the heat out and then being able to move that heat elsewhere to reject it. So like I said before, we can reduce our energy costs significantly, sometimes more than half. We talk about reliability. One of the things about reliability that you have to remember with submersion cooling, the graph you're seeing right now is the GPU temperature versus time running a GPU the benchmark application. As you can see, as the application starts running, you see the temperature ramp. The top line is red. The red line is a air-cooled GPU. The blue line is a fully submersion-cooled GPU, which, by the way, is 60% overclocked in this case. But even then, you notice that temperatures ramp much more slowly. They cool off much more quickly, and they tabletop at a much lower temperature. In this case, 30 degrees Celsius less, roughly. So your parts see much less thermal fatigue, and they run at lower temperatures, which means less chance at bit failure, or in the case of a GPU doing graphics work, or something like a artifact forming in the image. So in the end, you're much more reliable because you're doing much less thermal fatigue on the part. And cooler parts last longer. It just stands to reason that the cooler you run a component at, the longer it's going to last. This graph shows motherboard statistics, time before failure versus temperature. And we're running within the 35 to 40 degree range, roughly. And you see how much the mean time before failure falls off below that. So we're actually allowing you to run for the full 3 to 4 year lifespan of the product versus sometimes in hot data centers the failure points are a matter of months. Our core computer, we take the technology we're developing very seriously. We now have 10 U.S. patents, which very well picket fences us in the market. We've thoroughly protected and own the space for submersion cooling. And we recently, just within the last month, added 3 more patents granted in the area of rack-mounted cooling solutions, which goes along with the launch of our LSS products. And you can see here in the next succession of slides how our solution works. We have a aluminum extrusion. It's a patented design. We have a simple aluminum extrusion. And on the inside, we have something we call our core, which is a tray that holds a motherboard, power supply, in this case up to 6 2.5-inch solid-state drives, and PCI Express cards. And we can pack these extremely dense and get a lot of technology in a very small amount of space, allowing a lot better space utilization than traditional air-cooled or hybrid-cooled solutions. And you can see it. We fill that up with liquid. Cool liquid comes in the bottom connector in the back, cycles through the system, and across all the hot components. Everything's in direct contact with the liquid, so you're only good as the weakest link, but every capacitor, resistor, MOSFET, anything on the board is in direct contact with that liquid and allows it to be conducted directly into that liquid and then cycled outside the system. And the beauty in this is rather than with air cooling or hybrid cooling, where even with hybrid cooling, the CPU may get adequate cooling, but you're still 80% of the heat being produced from the motherboard is going into air, and then you have to push that air somewhere else, and using cold doors or some other chill door technology or other types of air conditioning technologies just push that inefficiency out further, and it really becomes a Rube Goldberg solution. With us, it's very simple. The heat's in the liquid, and then you can vector that liquid anywhere you want. In fact, you can use it for beneficial purposes, put it into in-floor heating systems in the wintertime, like in Minnesota here where it gets pretty cold, is one example. But there's a lot of other things you can do with it. But the point is you can vector it somewhere else and deal with it outside the data center rather than having to spend a lot of money on expensive air conditioning systems in order to maintain a cooler environment. You see here a shot of the back of one of our rack systems. And you can see it's a standard 19-inch rack. We mount in our manifold systems on a shelf. And you can see here the quick disconnects that I mentioned earlier, where these systems simply plug and play to the back. And you can cycle the cold liquid in, hot liquid out. And everything else is cabled up like a standard discrete server, where you've got your I/O and power connections in the back. And everything else is set up like a standard server. So if you've got existing rack space you need to retrofit, we've got a solution for you. If you look at this image here, this just shows what the systems look like from the front, and our shelf system that's locked into place in the rack. And once you screw the rack shelving in and the manifold in, you simply slide the systems in from the front until they click into place, and you're good to go. Here you see a fully populated row. As you see, there's 8 systems in a 5U rack height. Extremely dense, and each one of these has the ability to do 1 or more PCI Express cards, up to 6 SSDs, and we have a variety of different combinations of I/O and connectivity inside to work with, and this is all fitting in a very tight package. And the other nice thing about this is you don't have to worry about blocking panels or airflow requirements. You can actually fully populate an entire rack with these systems without having to worry about gapping and allowing for cold aisle or hot aisle containment, because all the heat's contained in the liquid. You can simply vector it elsewhere. What does that allow for? Well, what that allows for is a reduced footprint in your data center. As you can see here, if you remove all the air conditioning and other plenum space and anything else you need for a hot aisle, cold aisle containment, you can get things in a lot smaller space. And because we're getting more on the rack level, you even get further data center consolidation. So we can cut your data center space requirement, whether it's white space build out or retrofitting existing space, and you just want to get more systems in an existing space, we can cut your data center space requirement by 40%. This is just kind of an illustration of what things look like before with air-cooled or hybrid-cooled solutions versus our solution. Much more compute density per rack. Some of the additional benefits of submersion cooling that some people don't consider are the fact that you can take that heat from the data center and do things like preheat the boiler water in a facility space. You get additional boiler water efficiency. You can do things like I mentioned before for office heating. There's a real potential. Geothermal is some exciting research going on right now in geothermal, being able to actually generate electricity from waste heat going into the ground. There's a thermal differential there. You can create an engine and actually generate electricity that sends that back in the data center and get additional efficiencies. And with everything submerged and surrounded by a dielectric liquid, there's no oxygen exposure. And without oxygen exposure, there is no potential for fire. So fire suppression is actually built into our design. And I mentioned before, the harsh environment operation is also, these things are virtually deployable anywhere as long as you do a good job of removing the heat somewhere else. And these are modular plug-and-play design. It's ideal for modular data center deployment and also for containment, external containment systems. Modular storage containment, for example, where you're bringing in storage modules full of data center equipment and be dropped into place. Typically, half the space is being taken up by air conditioning systems. Now you can fully populate it with compute space. So there's a variety of different things that this technology enables. It really allows data center designers to rethink how they set up a data center. And it makes it much more easy for them to deal with things like temperature control, environmental controls, etc., and also space management. So we've had a lot of great talks with M&E groups around the world, and a lot of people are pretty excited about what kind of opportunities there are for deploying the systems in their data centers. And on top of that, we're also a very green technology. And we're not just painting this green, and calling it green. It's actually a truly green product because we're reducing energy consumption through the removal or considerable reduction in air conditioning requirement. We're saving, I mentioned before, 8% reduction in energy costs through cooling, and that leads to as much as 50% reduction of energy costs overall. And we can reclaim heat, we require less space, renewable and recycled materials are being used. Our chassis are aluminum and recyclable plastics. And the liquid we're using is potentially infinitely recyclable. And it's also very biodegradable. And so disposable. It's something you can actually drink. We joke that we let our salespeople do that, and they don't go too far from the bathroom afterwards. But it is something that could actually is a food-grade product. So it's very environmentally friendly. It actually breaks down better in the environment than vegetable oils do. It's giving you greatly improved power usage. And this really leads to an overall significant reduction in carbon footprint. And when you consider right now in the U.S., they're saying that 3% of power usage is going into data centers, and they're not even talking about the availability on top of that that's required. There's a lot of room for improvement on what we can do to help out power consumption in the data center. And with our ability to cut that cost in half, that requirement in half, I think that makes us a very green player in the market.
Well, thanks for that, Chad. So a couple of technical questions. Want to double click on this technology. When you were talking about what's inside the module, do you have to take the disk drives and do them externally, like spinning disk? Because you certainly wouldn't want fluid to get into that enclosure, right?
Yeah, that's a good question. We actually have patents on how you submerge a spindle drive. We've had spindle drive submerged for 5 years plus running, and no problems. Requires putting snorkels and things on breather holes, and in order to be done properly. And we have, like I said, we have the patents on that. Other people don't have those kind of considerations. We can do it. We choose not to because of the emergence of solid-state drives and the performance benefits and the power benefit of using solid-state drive technology. It can be directly submerged. We go that route. We tend to go that route with the technology. So it is possible, and if we ever had a large-scale customer requirement for it, we could go with spindle technology, but right now, pretty much our market is in solid states.
In solid state. So, and then what's the delta temp from the fluid coming into one of these things and to what comes out? I mean, how much of a differential is there?
That's a good question, and it depends on what you have inside. But typically, our system's baseline, 300 watt range. But if you're doing GPU or other type of power intensive daughter card in there, we could go up over the 500 watt limit per system.
Mm-hmm. Yeah.
But it's really in the 5 to maybe 7 degrees Celsius temperature delta between inflow and outflow. And we can take inflow temperatures up to 35 degrees Celsius, and potentially 35. More depending on depending on what we put in there. If we're using lower power processors, we can actually get away with a lot higher inflow temperatures than that.
So that I guess brings the next question. What about warranty? Like on these Xeon processors, did you have to work with Intel to make sure that you weren't voiding the part warranty by this submersion technology?
Yeah, that's a good question. We've got a great relationship with Intel, and we're fully warranty supportive of the processors. We've never had a return because of overclocking or submersion issues, and knock on wood, so far so good. Everything has been going very well. In fact, like I mentioned before, because we're keeping them cooler, we've actually have the ability to get better reliability out of those processors. And and because we're also keeping them cool, we were selected by Intel to be one of the few customers of Intel that can sell the Everest processors, and which will allow us to go 4.4 gigahertz as a base clock speed, and we're actually overclocking those for certain customers up to 4.8 gigahertz.
And Chad, it seems like the old AMD processors were very friendly to overclocking. At least they made it easier for the gamers. Do you guys do AMD as well?
We do offer an AMD product, and it's based on customer requirement, but we do support the latest AMD technologies as well.
Well, terrific. Well, I guess kind of a wrap-up question here, Chad. I mean, you guys have been out there for a while with this. What kind of reactions are you getting when you deploy these and a customer gets to see the benefits for themselves? What are they telling you?
Well, we've been out there with beta for about a year and a half right now, and the people we've gotten these in the hands of are really enjoying working with them. From the performance benefits, but also the potential for energy reduction. And since we just launched the product this last fall, and we're working on getting some of our initial larger scale deployments out there. We're hoping to get a really good story to tell here in the near future about how much energy we're saving once we have that track record in place. But we definitely have a lot of customers that we're talking to now, and for example, we're in the process of doing an installation at the New York Stock Exchange Euronext Data Center and in Basildon, UK. And they have a state-of-the-art data center that was just opened in 2008 that has chiller water. I mean, they even have solar panels on the roof. So they're extremely progressive data center, and they're very excited about the opportunity of working with us because we can actually take advantage of the wastewater lines in their chiller system and get free cooling for our equipment.
Oh, terrific. Well, Chad, I can't let you go without asking you about Scott McNeely, like how he got involved and what his role is at the company.
Scott McNeely is an advisor to our board, and he's a great source for information and a good sounding board for what we're trying to do in the industry. He's also a great advocate for what we're doing. He believes in the products and the technology that we're trying to bring to the market. And he came in actually through a series of contacts. It's kind of a direct connection to one of our venture capital firms that backed us. So we got an introduction through them, and it's been a good relationship. We enjoy talking to Scott and working with him.
That's terrific. Well, Chad, I want to thank you once again for coming on the show today.
Thank you. Appreciate the opportunity.
You bet. Okay, folks, that's it for the Rich Report. Stay tuned for more news and information on high-performance computing.